Imagine a tiny bacteria colony is right now eating away at your million-dollar data center's cooling system, and you won't know until the whole thing shuts down, costing millions of dollars in just hours. That's the real nightmare keeping data center operators awake. Here's why. As AI chips get more powerful, they need more aggressive cooling. So engineers are mixing more water into those liquid cooling systems. Water absorbs heat way better than traditional oil coolants. The problem, more water means more bacteria thrive. Once bacterial growth starts clogging the pipes, you're looking at 5 to 6 hours of complete system shutdown while technicians flush everything out. That's not just downtime, that's a business-destroying disaster for companies running trillion-dollar AI infrastructure. This week, a startup called Omen AI dropped a spectrometer device, basically a tiny real-time sensor that watches your coolant chemistry constantly, that catches bacterial contamination before it becomes catastrophic. This isn't glamorous. This is the unglamorous behind-the-scenes technology that actually keeps the entire AI revolution running. CEO Zach Labbage's company isn't stopping at bacteria detection either. The spectrometer also spots component wear by detecting metals like copper and chromium, and it catches seal degradation by identifying silicon in the fluid. And here's where the story gets interesting, because the market is already crowded, and Omen's tiny device just showed up to compete with an established player. So let's back up. Traditional data centers used air cooling, giant fans blowing cold air across racks of servers. Simple, reliable, ancient, but AI chips are absolute heat monsters. A modern GPU running intensive AI workloads can generate thousands of watts of heat in a space smaller than a sandwich. Air cooling just can't keep up. Engineers realized they needed something way more efficient. Enter liquid cooling instead of air. You run specially formulated coolant, think of it like blood in a computer's veins, directly through channels carved into chips and components. The coolant absorbs heat way more efficiently than air ever could. It gets pumped through radiators and coolers outside the chip, dumps the heat, and cycles back for another round. This is why every hyperscaler building the next generation of AI data centers is switching to liquid cooling. Google, Microsoft, Amazon, they're all betting big on this technology. But here's the catch. The most effective coolants for absorbing heat are water-based. And water, unlike synthetic oils, is a perfect breeding ground for bacteria, algae, and all kinds of biological nasties. Mix in dissolved minerals from the water, tiny metal particles from the system, and you've got a Petri dish. Engineers can fight this with biocides and water treatment, but that's like playing whack-a-mole. You're constantly adding chemicals, testing, adjusting. This is where real-time monitoring becomes essential. Here's what happens when bacterial contamination goes unchecked in a data center's cooling system. Bacteria form biofilms, slimy colonies that stick to pipe walls. These films thicken gradually, clogging the flow. At first, the flow rate drops slightly. Operators notice coolant temperature creeping up, but they think it's just the chip working harder. Then the clogging gets worse. Coolant can't move fast enough. Heat builds up. Temperatures spike. The system safety protocols trigger, chips throttle back, performance plummets, and those billion-dollar training runs slow to a crawl. If nobody catches it fast, the system shuts down entirely to prevent permanent hardware damage. Technicians get called in. They drain the entire cooling loop, flush it with special solutions, replace corroded components, refill with fresh treated coolant. That's 5 to 6 hours of complete downtime. In a hyperscaler running billions of dollars of AI work, 5 hours isn't annoying, it's catastrophic. We are talking millions lost per hour. Omen's insight is elegant. What if you detected bacterial growth weeks before it becomes a clog? What if you had a sensor showing exactly when to act? That's what Omen's spectrometer does. It measures the optical properties of the coolant, basically how light passes through it. Different contaminants scatter light differently. Bacteria blooms. The light signature changes. Metal particles from corrosion, different signature. Omen's algorithms instantly recognize these patterns and alert you before catastrophe strikes. So how does Omen's spectrometer actually work? Think of it like a tiny microscope for your coolant. The device sits in the cooling loop, or samples the coolant periodically and shoots light through the fluid. Clean, healthy coolant, light travels through it in a very specific way, but contaminated coolant scatters that light differently. Bacterial growth creates tiny particles that break the light path. Dissolved metals like copper or chromium, signs of corroded components, scatter light in distinctive patterns. Even silicon, which indicates seal degradation, has its own light signature. Omen's algorithms were trained to recognize all these patterns instantly. The sensor runs continuously, feeding data to monitoring software that alerts operators the moment something's wrong, instead of waiting for a filter to clog or a temperature gauge to spike. Operators know weeks in advance. You've got some bacterial growth starting. Run a preventive flush this weekend. That's not a $5 million emergency shutdown. That's a scheduled maintenance window where you plan the work around your workload. The beauty of real-time monitoring is prevention instead of crisis management. You also get detailed insights into coolant chemistry, not just something's wrong, but specifically what's wrong. Metal contamination suggests a specific component is corroding. Bacterial growth suggests biocide levels are dropping. Silicon indicates a seal is failing. The spectrometer gives operators the data they need to address root causes, not just symptoms. Now, Omen AI isn't the only player in the data center coolant monitoring space. Just earlier this month, a company called Pyxis rolled out its own water monitoring product for data centers. Pyxis has been in the game longer. They are an established player with relationships across the industry. Omen, by contrast, is a young startup founded by Zach Labbage. On paper, that puts Omen at a disadvantage. Pyxis has the track record, the sales infrastructure, the customer relationships. But here's what's interesting. Even with an established competitor, data center operators and hyperscalers have been vocal about their respect for Omen's approach. TechCrunch reporting suggests that Labbage has earned credibility with the massive corporations that actually buy this equipment: Google, Microsoft, the rest of the hyperscaler crowd. That's rare for a young founder. Most startups take years to break into enterprise relationships at that level. Omen's done it faster, which tells you something about the quality of the solution or the founder's track record before launching Omen. The real story isn't Omen versus Pyxis. It's that both companies existing means the market is waking up to a real need. Hyperscalers are investing in liquid cooling at unprecedented scale, and that means monitoring technology is suddenly critical infrastructure. Two competing solutions emerging so close together signals that this market is accelerating. The winner might be whoever builds the ecosystem fastest, integrates best with hyperscaler infrastructure, and proves reliability over time. So why does Omen AI's spectrometer matter beyond data center engineers? Here's the core. Liquid cooling is now the foundation of next-generation AI infrastructure. Every major AI breakthrough, every cutting-edge model training run happens on liquid-cooled chips. If those systems fail, the entire AI research pipeline stutters. Hyperscalers spend billions on chips, power, and cooling. A single unplanned outage costs millions. So monitoring isn't a luxury, it's essential infrastructure. Omen's spectrometer does something crucial. It turns random failures into predictable, preventable problems. That changes the economics of AI infrastructure. Fewer emergency shutdowns, more uptime, more reliable research cycles. Hyperscalers can push systems harder without fear of unexpected catastrophic failure. From a market perspective, this also reveals something about venture capital and hardware startups. Omen raised funding to build a tiny sensor, solving a critical but boring problem for a massive industry. That's unsexy. That's infrastructure innovation nobody thinks about. But it's exactly what actually moves the needle on AI capability and cost. The companies building picks and shovels for the AI gold rush, boring infrastructure layers, often become quietly valuable. Omen's spectrometer might be that kind of play. Real-time coolant monitoring could become as standard in data centers as fire suppression systems. And every hyperscaler deploying liquid cooling in the next 5 years might standardize on this type of sensor. Here's how this works in a real data center. Your cooling system constantly runs, liquid flows through chips, absorbs heat, cycles through radiators, loops back. Omen's spectrometer sits in the main loop, continuously monitoring the fluid. It takes readings every few minutes, sending data to cloud-based monitoring software that Omen provides. Algorithms analyze the light signatures in real time. Bacterial growth appears, flagged instantly. Metal contamination exceeds safe levels, immediate alert. Silicon indicating seal degradation, your team is notified. The operator dashboard shows exactly what's happening in your coolant at any moment. Instead of waiting for symptoms like temperature spikes or flow rate drops or actual failures, you're acting on early warnings. This is retrofit compatible. No need to rebuild your entire cooling system. Install the spectrometer in your existing loop. Connect power and networking and you're done. The software handles everything else. Omen engineered the spectrometer for hyperscale reliability. False alarms waste millions, but so do missed detections. Real-time data becomes part of your operational database. Over time, you have complete coolant chemistry history. You predict maintenance windows accurately. You optimize biocide dosing. You predict major component failures before they happen. The data becomes an operational asset. You understand degradation patterns specific to your system. That knowledge is money. Here's what Omen AI's spectrometer really represents. AI infrastructure is maturing at speed. We're moving past early days where hyperscalers threw unlimited resources at cooling problems and just hoped systems didn't fail catastrophically. Now we are seeing real, thoughtful engineering solutions built specifically for the demands of next-generation AI compute. Liquid cooling isn't a nice-to-have feature anymore. It's an absolute requirement for AI infrastructure. And real-time monitoring of that cooling isn't a luxury, it's becoming standard practice. The fact that Omen and Pyxis are both bringing products to market simultaneously, competing for contracts and mindshare, tells you this infrastructure transition is serious and accelerating. For you watching this, here's what this means. Every AI breakthrough announced next year, every cutting-edge model from major labs, is being trained on infrastructure increasingly relying on technology like Omen's. You'll never see the spectrometer, you'll never touch it, but it's sitting inside the machines reshaping AI. That's the nature of infrastructure innovation, invisible, unglamorous, absolutely critical. The revolution doesn't happen on chips and algorithms alone. It happens in the cooling systems, keeping those chips from melting. Omen AI just proved they understand that better than anyone. Follow for daily AI news to stay on top of the unglamorous innovations actually moving the industry forward.